Okay. So, I believe Mr. Brzezinski has gotten to what is called rational expressions. Okay, so rational, the root word there is ratio, which of course means a fraction. And I want to go over some things about fractions before we dive into actual rational expressions. So first, a fraction is composed of two numbers. And the idea behind the fraction is that we're expressing division here. So 6 divided by 8. Now, of course, we could plug 6 divided by 8 into our calculator and get an answer, some decimal. But a fraction is what we call an exact answer. Many times when we enter something like this into our calculator to divide, it gives us a huge, long decimal that we have to write down. And, well, many times we have to round it. A fraction gets around that by just saying the numbers that we have to divide in order to get that decimal. Okay? Now, this fraction in particular is actually not the simplest way that we can say this fraction. In other words, we can reduce it or simplify it. So, how can we simplify it? I'm sure somebody here knows. By what number? 2? Okay. So if we divide both of the numbers, the top and bottom numbers, by 2, since they can both be divided by 2, we get 3 over 4, 3/4. This is the simplest way to express this fraction. They say the exact same thing. They have the same value behind them, but this is a simpler form. Now, another way that you can look at this idea is to say 6 and 8 have factors. So what are the two factors of 6? 2 and 3. And what are the prime factors of 8? And of course we can split 4 up into 2 and 2 as well. But we'll stop here because this is actually easier. Notice that this is 2 times 3 on top and 2 times 4 on the bottom. But between the top and bottom we are dividing. Well, multiply and divide are opposites, aren't they? So, in theory here, what we can do is if any numbers are common between top and bottom, if there are any common factors, we can cancel them and just be left with the numbers that are uncommon. So when we are simplifying like this, dividing both of these by 2, what we're really saying is both of them have a common factor of 2, and we can cancel that 2 out. Make sense? Any questions? Okay, another thing I want to talk about. If we have fractions that we are multiplying, it's quite simple. All we do is we multiply the top numbers and multiply the bottom numbers. So 2 times 1 is 2, and 3 times 2 is 6. Now this can be reduced, right? Both of them have a common factor of 2, which we can actually see back here. This 2 and this 2, we have a 2 on the top and a 2 on the bottom. This is actually the same as having the 2 on top and the 2 on bottom like we had up here. We can cross-reduce this. So again, if we have a common factor on the top and on the bottom, we can cancel it out. So instead of getting 2, 6, which is the more complex form, we can reduce it back here. Now, these are both 1s. 1 times 1 is 1. 3 times 1 is 3. Which, of course, 2 6 would reduce down to 1/3. So we can either multiply and then reduce, or we can reduce before we multiply and immediately get our simplified form. Does that make sense? Any questions? Okay. One more thing. So let's say that I have fractions that I'm dividing. Okay? What do I do with these fractions if I want to divide them? Is what? Okay? So think about it like this. We're dividing by division. It's like a double negative, right? So it's really like multiplying. But if we flip this to multiply, this also flips to its reciprocal. One way you might have heard this is you multiply by the reciprocal, but the one that most people are commonly familiar with is you keep, change, flip. So when we divide fractions like this, we keep the first one just the way it is, change this to multiply, and flip this one to its reciprocal. So now, 4 times 3 is 12, and 5 times 1 is 5. And did we have any common factors on top and bottom here back in our problem? No. So can we expect that this is the simplest form? Absolutely, yeah. If we didn't have any common factors back here, we don't need to worry about them over here. In fact, 12 and 5, yeah, they don't have anything that can divide both of them. Okay. So these are some of the basic ideas for fractions that we need to keep in mind moving into this next section with rational expressions. Okay. Any questions before we move on? All right. Next, let's actually take a look at a rational expression. Rational expressions will often look something like this. Okay, so we'll have some different operations going on top and bottom. It's not just going to be a single value. But the ideas for fractions that we just went over still apply. So if we have anything common as a factor between the top and bottom, we can eliminate it. So do we see any common factors here? Yeah. Just like before where we were saying that 6 is really 2 times 3 and 8 is really 2 times 4. Well, these are multiplying, aren't they? They're parentheses right next to each other. They are factors. So x plus 2 and x plus 2 are common, meaning that this can be reduced to x minus 4 over x minus 3. Any questions? None? Okay. Now, this is about as simple as it can get. Let me show you an actual problem. Oh, actually, before that, let's do something else. Before we move on from this problem, there's something we need to keep in mind about it. Okay? And that is, since we have fractions here, and we don't know the exact value of x, there's actually some things we can't plug in for x. And that would be anything that would make the bottom equal to 0. Okay? So with this original thing here, we have two factors, x minus 3 and x plus 2. And again, we cannot have anything that we can plug in for x that would make the entire bottom 0. Well, x minus 3, if it ever comes out to be 0, that would be 0 times this would make the entire thing 0. Same thing with this, x plus 2. If we plug in something for x to make this part 0, then 0 times this would make the entire thing 0. So we have to say, all right, x minus 3 can't come out to be 0, and x plus 2 cannot come out to be 0. So we then solve them, add a 3/8 to both sides to get x cannot be equal to positive 3. Subtract 2 from both sides, and we get that x cannot be equal to negative 2. Okay, so that's something very important to keep in mind when we're working with rational expressions, is that since they have x in them typically, they're going to have, something that we can't plug in for x. Otherwise, it's going to make the entire thing break, because we can't divide by 0. Now, if we were to have something like x plus 1 all over 2, well, there's nothing that we can plug in for x that's going to make the bottom 0. There's no x on the bottom. We can plug in whatever we want here. There's no restrictions. This is what's called a domain. Domain is the rule for what we can plug in for x. So in this case, the rule here is we can plug in whatever we want for x. It just can't be positive 3 or negative 2. And then our domain for this one, well, we can plug in whatever we want for x, so it's all real numbers. Okay, any questions? All right, so now let's move on to something a little bit more complicated. So we have here Get a different one. Bless you. Bless you. Yeah, that's a good one. We have here z squared minus 14z plus 48 over z squared minus 36. So we've got a trinomial divided by a binomial. And what we want to do here is we want to simplify it, very much like we did this, and find the excluded values, anything that we might not be able to plug in for z. Okay? So, first things first, we can't see the factors of this thing right now. They're tied up in these polynomials. We need to factor them so that we can actually see if they have anything in common between the top and bottom. So let's start with this one right here, z squared minus 14z plus 48. It's a trinomial, so what method are we going to need to use to factor it? Anybody remember? It was a while back. Okay, I'll give us a hint. All of these trinomial things, these quadratics, are in the form ax squared plus bx plus c. And the method we use is two of these letters. AC, excellent, yes, AC method. So the AC method tells us to take our A and our C and multiply them. So what is our A, the number in front of z squared here? 1. And our C? 48. So 1 times 48 is 48. Then AC tells us to take this number and find pairs of numbers that will multiply to get it. And we want a positive 48. Negative 8 and negative 6 will indeed multiply to get positive 48. And will they combine to get negative 14? Yes. So that's our goal here. We want to find pairs of numbers that will get this when they multiply, but combine or add to get this number in the middle. So now that we have that, we can rewrite this as z squared minus 8z, for that 8 right there, minus 6z, for that 6 right there, plus 48. So just replace that 14z with negative 8z and negative 6z. Then we can go to our box or well, there's a shortcut, but I'll show it in a second here. But we can go to our box and start filling things in. So the first term, z squared, goes in the first box. Last term, 48, goes in the last box. Then these two in the middle, doesn't really matter which one they go to. I'll just put 8z here. But its sign has to go out somewhere, and it has to go up to the top. If I put the number here, its sign has to go up top. The number I put here, which in this case is 6z, its sign has to go to the side. So now we can factor this. This row right here, these two numbers, what do they have in common that I can divide them by? Yeah, the common factor is z. How about this row, 6z and 48? 6. This column, z squared and 6z, z. This column, 8. So factoring this, we get z minus 8 and z minus 6. Okay, now for that shortcut I mentioned. Again, I'm pretty sure I went over this, I think last week. But what is the leading coefficient on this polynomial? Is what? 1, positive 1. If the leading coefficient on your polynomial is positive 1, once you get to this point, you can use these numbers to make your factors. Just take whatever variable you have, put it down, take whatever numbers you got from your pair, put them in. But that only works if you have a leading coefficient of positive 1. If you have a leading coefficient of positive 1, you can skip the box part. If this is anything else but positive 1, you need to do the box part. All right, next, we need to factor this one. This is a binomial, so first we need to see, okay, does it have a GCF? Can we divide z squared and 36 by something? No, we can't. Is it a difference of squares then? Yeah, it is. Z squared is a square of z. 36 is a square of what? 6. So, we know that difference of squares comes out to be 2 factors. What are they going to be? Yeah, z plus 6 and z minus 6. We take the square root of these numbers and fill them in. One of them has a plus, one of them has a minus. It'll always have a plus and a minus. Okay. So now, are there common factors between top and bottom? Yes, what are they? Z minus 6. We can cancel those out. We also need to know the excluded values. Okay? Now again, in a rational expression, the only place that you're going to get an excluded value is if the bottom becomes 0. So there's 2 places that it could become 0. Z plus 6 can't be 0, and z minus 6 can't be 0. Because if either one of these factors became 0 from plugging something in for z, it would make the entire bottom 0. So, again, solve these. Minus 6 to this side, so z cannot be equal to negative 6. Plus z to this side, so z cannot be equal to positive 6. There's our excluded values. So our final answer is z minus 8 over z plus 6, where we cannot have negative 6 or 6 for z. We would basically say z cannot be equal to plus or minus 6. Okay? Any questions? Making sense? All right, let's try another. Okay, I like that one. Let's see, z to the fourth minus 4z to the third over z squared plus 2z minus 24. And again, what we want to do here is we want to simplify and find the excluded values for z. But of course, we need to factor this thing in order to be able to see if there are common factors between top and bottom. So let's start with this top part. What can we do to factor it? So first, do they have like or common factors? Do they both have something they can be divided by? Z to the what? To the third, yeah. When all else fails, they have at least the lowest power in common. Okay, so they both have z to the third in common. We can take a z to the third out, which gives us z minus 4. Can this be factored farther? Yes, no? It's not a trick question. No, you can't. Okay? So, now we need to factor the bottom part. So again, what method do we use to factor this trinomial? AC. Now it's also a good idea to see if they can be divided by something, but we haven't gotten anywhere close to that kind of thing. So, AC method, what's my A? 1. What's my C? So A times C, 1 times negative 24 is negative 24. Will we be able to use our shortcut on this? So in other words, is our leading coefficient positive 1? Yes, so we can use our shortcut. So let's find factors, negative 1 and positive 24. What else? I heard 2 and 12, 6 and 4. Do we have what we need? Yes. Which one? Good. So negative 4 and positive 6 will multiply to get negative 24, but we'll also add to get positive 2. So again, we can use our shortcut method here since we have a leading coefficient of positive 1. So what are our two factors? Z minus 4 and z plus 6. Excellent. All right, so now, where can we reduce this? What do they have in common? Z minus 4. Okay, so those are out, which means the simplified version is z to the third over z plus 6. Now we also need to get our excluded values. Okay, so where do we get excluded values? What two factors are going to give us excluded values? Look back over here. Which of these factors? Okay, let me ask you this. What part of the fraction cannot be 0? The bottom. So z plus 6 is one of them that cannot be 0. Good. There's another though. Which other one? Z minus 4. Okay, so both of these cannot be equal to 0. Okay, so in this case, z cannot be equal to what? Negative 6. And in this case, z cannot be equal to what? Good. So our excluded values, or our domain, is z cannot be equal to negative 6 and 4. Good. Any questions? None? Okay. Try another. Where's what I'm looking for? I could do that. All right. Let's try this one. Get ready, because this is going to be a long one. 2y squared minus 13y minus 24 all over y minus 7 times y squared minus 13y plus 42 all over y minus 8. Okay. Same thing. We want to factor this, see if we can reduce things, multiply, tell what our excluded values are. Okay? So let's see what we get. Okay, so let's factor this one. Now, is my leading coefficient positive 1 on this one? No. So can I use the shortcut on this? No. We got to go through that box method. Okay. Can I take out a GCF? Do all three of these numbers have something in common that they can be divided by? No. So got to use AC method. So my A is what? 2. My C? Negative 24. So my 2 times negative 24 AC is what? 2 times 24? 48, yeah. So we have negative 48 for our AC. And we want a pair of factors that will multiply to get negative 48, but add to get negative 13. Any ideas? Any? 1 and 48, 2 and 24, 4 and 12, 6 and 8. There we go. Okay, so these are all the numbers that can multiply to get 48. Again, one of them needs to be positive, the other one needs to be negative. So which one will do it for us? Any ideas? Okay. Give me a second here. Okay, we're missing a factor. We did 1, we did 2, we did 4, we did 6. There's something in between. What? 3 and 16. There we go. So 3 and 16, if we make this a negative 16, gives us negative 48 when we multiply, and negative 13 when we add. And remember, we can't use our shortcuts, so we got to go through the box method. So what's going to go in the first box? 2y squared, good. Last box? This box. 3y. And what goes up here? Okay, here? 16y, good. And here? Good. All right, first row, what can come out? Y. Second row, what can come out? Is what? 4? Good. Something bigger maybe? 8, yes. Okay, so we can take an entire 8 out of that. How about this column? 2 and y. This column? Okay, so our two factors are 2y plus 3 and y minus 8. And it's still over y minus 7. So do we see anything we can reduce right now? No. Huh. Let's move on. Let's see if we can get anything out of this. So same thing, we have to use AC method here. What's my A? 4. Wait, 4. 1. What's my C? So 42. Okay, so factors of 42. 9 and 6, and then what? There we go, that's what I was looking for. Okay. So negative 7 and negative 6, there we go, gives us a negative 13 when we combine it, and positive 42 when we multiply. Do we need to go through our box method? No, because our leading coefficient is positive 1. So what are our two factors? And good. And it's still over y minus 8. Okay. So, do we now see any factors that we could cancel out? Something common between top and bottom. Y minus 7. Does not matter that they're on opposite fractions, just like we saw in the beginning. We can reduce them even if they're on opposite fractions. Anything else? Y minus 8. Also common. So, what we get at the end here is y minus 6 times 2y plus 3. There's nothing left on the bottom, so we don't have a bottom to write down. But we still need our excluded values. So what am I going to look to for excluded values? So we have y minus 7 cannot be equal to 0. And y minus 8 cannot be equal to 0. So what are my two excluded values? Y cannot be equal to what? Perfect. There we go. Any questions? None? All right. I think that'll do it for today. I'll go into the rest of this stuff on Wednesday, yeah. Okay, so we will have a quiz this week. That'll be on Friday. It's mostly going to be this rational expression stuff, and I'm going to put in 1 or 2 questions about the sets that we were talking about last week. So I will see y'all on Wednesday, and I hope you have a great day.
Is the quiz going to be sent in again?
Yes, it's always going to be like that.
That won't be required.
Yeah, just look for it in your email, and once you get it, send it to me once you're done.
And then did you get my test? I don't know what was going on with the email.
I'm pretty sure I did. Let me check. Last name?
Bro, B-R-E-A-U-S.
You sent it in through photos, right?
Pretty sure.
Exam 1. Yeah, this is it, right?
Yes.
Yep, I
I
got
don't know what happened the first time, but I was like, what do you mean I didn't? I sent it in.
it. I don't know, because I remember that happening, and it's just weird.
Okay.
All right, thank
I
you.
just want to make sure.